I'd just like to give you a little bit of insight into the work that we in Tidal Energy Limited have done over the past few years, culminating in the deployment of Delta Stream in Ramsey Sound just before Christmas. So what you have to have in this game, I think, is a lot of stamina and a lot of finance at the moment. Now, from our perspective, our journey started as long ago as 2002, when the first test of a shed-like device a device out of a shed came into Claddow Estuary down here in 2002, where our founder, Richard Eyre, started the road which brings Tidal Energy Limited to where it is today. And Richard tested a 5-metre diameter turbine, and then I joined the company in 2007 with a task with Chris Williams, my co-director, who's here today, to take that vision of Richard's into something which is now in the water in Ramsey Sound on its way to commercial viability. Our design vision consolidated into a 3-turbine device on a single structure shown in this first slide here. We always have believed in multiple turbines on a single structure, looking always to levelise cost of energy and making efficient use of the infrastructure that we put on the seabed. But it's an expensive business to build something like this at full scale first off, and the device that we've actually put in Ramsey Sound is 1/3 of this 1.2 megawatt design vision. This is Ramsey Sound. So we have deployed the device at the north end of the sound with the cable linking through to the grid connection alongside the St. Justinian's or St. David's lifeboat station at St. Justinian's. It's a 1.2 kilometre long cable connecting the device, full grid connection. It's a special area of conservation, so we've had to be very cognizant of the marine environmental impacts, and that's really been an important part of our work over the last few years. So from that vision in 2008, the detailed design was completed, and then we assembled the device on the quayside in Pembroke Dock in 2014. An extensive process using local contractors, Mainstay Marine were the principal fabricator for our device down here, and the Port of Milford Haven gave us very welcome infrastructure support in enabling us to use the quayside Quay 1, which is an important part of their commercial framework. The compound, which houses the interface to the grid, was built in 2014 also on the top of the cliff at St. Justinian's, and you can see it here linking through to pictures through from sea into the grid connection along right at the back of the compound, that top picture at the top left. And that's also where we control the device from the control cabin there. But it's not been an easy ride at all. We have had our share of setbacks. We stayed too long in Pembroke Dock because social media quickly cottoned on to the fact that this daffodil was still on the quayside in Pembroke Dock and was there for longer than it should have been. But going back to my earlier comment, the fact that finance was a key part of what we need, our shareholder inputs slowed down because of slowdowns in their own business, which meant that we suffered some delay. And then we also had, in surveying the cable which had been laid on the seabed, we found a problem with it which needed reparation and which needed an extra £1 million or so to deal with. So these things don't just happen overnight. So from the initial readiness in 2014, in fact, through 2015, it was a protracted period of looking for that extra money, dealing with the cable issue, and moving on to installation, which happily, very happily, we managed to complete just before Christmas last year on December the 13th. The vessel, sorry, I've gone back too far. The vessel, CMDA-1, a specialist offshore construction vessel, was employed. We've actually benefited from the downturn in the oil and gas industry, which has enabled vessels like this, highly specialized vessels, to become available to us at really a quite affordable charter rate. 2 years ago, when we were tendering, it was unaffordable. But the availability, supply and demand equation meant that a vessel like this, extremely capable, could do the job for us. So we were delighted that CMDA came into Ramsey Sound to do that work for us. Looking forward, in terms of the experience we've gained since that successful installation, our job is twofold. One is to measure the performance characteristics of the device itself, and to see that it's doing everything that we predicted it would from our intense design calculations, computer simulations, etc. And happily, I can confirm that it does. It's generated electricity, connected into the grid, and we're very happy to see that performance characteristic coming through. We already know there are things that we can improve, and we're looking forward to that immensely. But a second part of our work was the environmental monitoring related to the Marine Special Area of Conservation. And my colleague Chris Williams will talk in much more detail about this afternoon. But a key part of our equipment was this remote acoustic monitoring platform, or RAMP, which is located actually on the seabed about 35 meters away from the main device itself, and that is collecting a vast wealth of environmental data to enable us to hopefully demonstrate that our device is having no adverse impact on the environment. And this is an industry of industry interest, and through NRW and through the network that has been developed through the UK, we hope to be able to share some of this experience to move our industry forward. The monitoring device, as you can see from this last bottom shot, just shows you what it's looking at. It's looking at the turbine. It's forming what we would like to call a tactical picture of movement of any objects, be they sea mammals or inanimate objects, around the device. And it also carries an acoustic Doppler to measure the current speed in the tidal flow. It was part of our performance monitoring characteristics. So there's a bigger shot of the ramp, which carries an active sonar device. It is connected by an umbilical cable to Delta Stream itself, and the sort of output that it gives us, it's perhaps difficult to see from distance, but that is a screenshot from the acoustic, the active sonar, showing clearly the turbine. If this point, you can just see the turbine here. Oh, sorry, too quick. Going too quick. Let me go back. Shows the outline of the triangle here. So the acoustic active sonar has been an important part, one part of a very comprehensive environmental monitoring suite that is on and around the device. For this year, we are continuing our monitoring. We will be planning an upgrade of the device. We have planned an upgrade of the device, and in fact we expect to be recovering Delta Stream from the seabed in the next couple of months in order to move forward on the O&M perspective. We want to make the nacelle a detachable device from the base frame itself, a really important part of our O&M philosophy for the future. So we're going to do that upgrade this year and get the device back in the water early next year. Right, I think I will call it a day just there.